Hello and welcome back to another video. In this video, so we have two more on-sites left, the Bloomberg and the Adobe. So we're going to do the Bloomberg one today. Let's see how we do on that one. Okay, and this one, given two trees if they're structurally identical. Alright, this one's easy. We just compare nodes and recurse in the same way. So if P is none, so basically if one of them is none, they both have to be none. So if P is none or Q is none, return, if we can just do this, none equals none. Yeah, I think this should work. Maybe we'll get a type error, I guess we'll see. Or yeah, maybe we'll get some comparison error, I guess we'll see. Maybe we can't compare none to a something, we'll find out. Okay, but anyway, so otherwise they have to be the same, and then the left and the right have to be the same. So return p-val equals q-val, and self is same tree, p left, q left, and same thing for the right, and that should be it. So not really much to talk about here. Basically just recursing the same exact thing. All right. Cool. Pow. Okay. So. Okay. So basically there's like it's like a, I don't know if it's like a dumb way to say, but let's see. 10 to the fourth. What are the constraints here? So n is 2 to the 30. N's like a really big number. Okay. And then okay, so x to the n is not like some massive number. Okay, so we're not concerned with like any overflow there. All right. So yeah. So I guess for POW, yeah, I guess I don't know if you're familiar with POW, but the way powers work is you can do it in logarithmic, or you can do it like kind of the dumb way. The dumb way would just be loop through the power and just keep multiplying that result by x. That's like the easy solution here. The better way is to split it in half. So, and this is just like how power is done. I've like made power functions before and stuff. But essentially, if you have like 2 to the 10th, what you end up doing is you end up getting 2 to the 5th. You get this value, and then you just multiply that by itself. So you keep splitting it in half like that. So if it's an even power, essentially you get half of it, and then you multiply that by itself. And if it's an odd power, then you get half of it. So if it's like 2 to the 9th, then that's basically the same as 2 times 2 to the 8th, and then you do the split here. So this is essentially what we could do. We can do this recursively. We can do it iteratively. Let's go with recursive, I think. Actually, yeah, I mean, we can go recursive with a cache. I don't remember if iteratively needs a cache. Yeah, let's go with a simple recursive. I guess that's going to be good enough. So this is basically going to be like a DP almost, where we have x and we have a power. So if n equals 0, return 1. If n is negative, we'll just do 1 over whatever that is. So if n is less than 0, return dp of x negative n, 1 over. Okay, so these are best case. The rest, yeah, essentially we can just do recursive. Yeah, I think iterative is better, but we'll go for this just because it's like an interview thing. If I was doing like a problem on it, I'd go further. But anyway, so if n mod 2 equals 1. So if it's odd, basically just do return x times dp of x n minus 1. And the other case is even. So then we can do return dp of x n minus 2 times dp of x n minus 2. And this will be cached, so this is fine. Okay. And just return send. So I guess let's think about it. So if it's 0, it's 1. If it's negative, it's 1 over. If it's odd, it's this. And if it's even, just split it in half. I think this is good. All right. Cool. Okay. Given an array integer heights representing the histogram bar height, each bar is 1. Okay. I feel like I solved this sometime, but I never really got how it works. Then if I did solve it, it was like years ago. So, and I do remember this being like really tricky in some weird way. Okay, so histogram bar height, area of the largest histogram. So I guess like we can't have n squared, so we need a linear in some weird way. How do we do linear? Okay, so like we have to, I think we have to record like old heights or something like that, I'm guessing, but how would we do that? Like if we recorded a 2 but now we get a 1, what happens? Like we probably need some like increasing or decreasing stack or some kind of thing like that for this. We just have to figure out like which way is it and like what do we record and how does this work, basically. So I guess let's look at this case. So if it's big and then it goes down, what does that mean? So if it's big and then it goes down. Okay, so I think if it's, I can write this down. So we had some like big value, smaller value. I think we can record like where did this big value start, and then this rectangle goes up until the smaller value. So we basically like delete big value, record rectangle, and then so delete big value is going to be step number 1. Record rectangle with big value, and then save smaller value starting at old big value. I think something like that is going to be the way to go, because so like we have this 2, so we'll store 2 starting at like index 0 or something. Then when we get to this, like this 2 can't continue, so we'll just record like how far this was, and then we will delete it and we will replace it with this value, and this value is going to start where the old value was, so it's actually going to start here. And then what happens when we get to a bigger value? So let's say now we have small value. And then we have, I think if it's equal value, we don't really care. We just ignore it. So small value to big value. What ends up happening here? I think we just keep both. And then when we delete the big value later, then we'll delete the small value. Yeah. So like if it's this case, we have to keep both. And then if we delete the big value later and we get a smaller value, then we'll do that old smaller value up until our new value. Yeah, I think I'm getting it. And if it's, so this is like case 1, case 2, case 3. And if it's equal value, then we just do nothing and keep the old one. Because, yeah, we don't really care. Yeah, so essentially we're going to record 2 things in this like thing. We're going to record start index and height. Okay, and then what happens when we get to the end? Then we like pop off. So I guess so we're going to have a stack of strictly decreasing stack. So let's say our stack is like some weird example, like 2 starts at 0 or 8 starts at 0. Actually, no. Big value, small, we delete. So it's going to be strictly increasing. Yeah, strictly increasing stack. So monotonic increasing stack. Okay, so let's say we go to 0, 6, 5, or whatever, and then 10 something. And our end index is like 12. Okay. And this is basically going to look kind of like this case. So like, let's say this is our whole thing, 156. Okay, so I think we pop off the last value, and that goes from where it starts to the end. Then we pop off this value, and that goes from where it starts to the end. And then we pop off this value. Okay, got it. So yeah, essentially imagine our thing was like this 156. We'd pop off the 6, and we'd say the 6 starts here and goes to the end. Then we'd pop off the 5, and we'd say the 5 starts here and goes to the end. And then the 1 starts here and goes to the end. Yeah, okay. I think this is it. All right, I think we're good. We're good. We just need to not screw anything up, and then I think we're fine. So I do remember this was like a really tough problem, and I feel like even though I saw the solution before, almost every time I tried to solve it, I just got stuck. So definitely feel like going through this and writing these things down, pretty happy with how quickly I came up with it, because I can assure you I do not remember the old solution. Okay, so, but yeah, from constraints, you know it has to be linear. Obviously, yeah, I don't even know if there's like an n log n, maybe. But obviously an n squared is doable. Like if you start at 1 and you go to the next, then you just keep track of like the smallest value in that range. So that one's easy, right? Like let's say you start here and you go to here. The rectangle in this range is just going to be the smallest height out of every index. So it'll be like this guy here. All right, so let's go with this solution. It's still not super easy to code, so we're gonna have a stack. We're gonna go for IV. We need an index. Yeah, we don't care about the value to the left. Like when we pop off something, it starts where we record it. So we don't really care about like things to the left, but we do care about things to the right. So we don't need to store anything initially, I don't think. We'll find out. Maybe we do. Maybe we need to store some like 0 at 0 or something, but I doubt it. Okay, so while stack and v, and then yeah, so we're going to store index height. So v has to be less, strictly less than stack -1, 1. Then we're going to say result equals max of result, and then stack -1, 1. And then how long does it go? So if it starts some index and then goes until this index, like let's say this is 0, this is 3. So it's 0, 1, 2. So this is just, this is 0, this is 3. It's going to be the current index minus where it started, -1. Is it -1? So if this is 0, this is 1, 2, 3. No, it's actually just going to be the current index minus where it started. Yeah. So times I minus stack -1, 0. All right, seems good. And we go stack pop. Okay, so if this value, I mean, if we push on the same, like if they're equal and push it on again, it doesn't really matter. Yeah, I mean, it doesn't really matter. We can just always push on if it's equal, because yeah, if they're equal, like it'll just, yeah, this is fine. So I guess we don't really care. Okay, so we're gonna go stack append. So yeah, I guess in this case, we can't add it. We can, I guess, let's just not to make it faster. So if stack and v equals stack -1, 1, continue. Otherwise, we'll do the add. So stack append. IV, right? Yeah, okay. Right. So now we have to do the stack cleanup at the end. So while stack IV equals stack pop. Right, so this rectangle goes from wherever it started to the end. So result equals max result. And then the V is the height. And then the length is, so I guess let's figure this out. So let's say this was index here. Let's say this was 5. So this is 5, this is 6, the thing is 7. So I think that is just also, this is just h minus the start index, right? 5, 6, this is 7. H minus I. All right, I think we're good. Yeah, definitely. This would be a huge pain to to do a dry run of this, so we'll do a dry run of the small guy instead. Easy. Okay. Okay, so this is our guy here. So this is index 0, this is index 1. So this is, yeah, I guess both of these are 4. Let's say this thing isn't 2, 4, it's like 3, 5 or something. Right, so let's say this is our heights. Okay, so in the beginning we don't have a stack, so we're gonna push on 3 at index 0. 5 is bigger, so we're gonna push that on as well, so 5 at index 1. Now we're gonna pop off this guy, and the length of this is 2. So the length is 1 times 5, which is 5, and the length of this is 2 times 3, which is 6. Yeah, I think this is good. I'm pretty happy with it. All right, let's go for it. And hopefully we didn't miss anything critical, just some small stuff. Ooh. So we did get this incorrect. I don't even know how we got 18. Let's see what we got for the second guy. Let's make sure that one's correct at least. Oops. Whoops. Okay, so what did we screw up? How did we get 18? Okay, so we'll add some logs to figure out how we got 18, I guess. Yes, so we'll go, anytime we try to do this, we'll log. So print this thing. Yeah, okay, let's just actually like store this in some like cur or something, just so we can get it. Okay, so this is that cur print. So this is going to be like stack -1. Let's just print stack -1 and cur. Same thing here. Print stack -1 and this. All right, so then we can figure out like where do we even, like where's our number that's too big? All right, where are we out of range? Here. Ah. All right. Okay. Because that one's good. Let's debug here. All right, so we got, how do we get 18? What? This. Wait, what? Let me run that again. So are we printing the right thing? We're printing res. No, we're not printing. We're printing stack -1 and we're printing cur. So how in the world did we get in that case, how do we get 18? What did I do wrong here? Like if we do cur again, stack -1, res v. I guess we don't have a v, that's why. Okay. IV. All right, we'll go with this and then we'll print IV. Okay. So it looks like it's the later path. So it's this part where we're screwing up. All right, let's take a look. Okay, here we go. 3, 6. So it starts at index 3 and its value 6. 1, 2, 3. Okay. Okay, so this should be popped because we got to a smaller value. So V is, oh, it's just the wrong way, right? Okay, that seems fine to me. Yeah, that seems fine to me. That's just a small problem, if that's it. Okay, hopefully that is it. Yeah, so I was thinking I missed something, but I literally just wrote it backwards, even though my logic here is correct. All right, let's find out if we're good. We're not. Interesting. Okay. So, okay, that's concerning. Okay, so this should be, How do we get 3 here, and what are we doing? Oh, I think I did miss one more edge case. So, and I don't know if this always happens. Yeah, so this one is actually, I did miss this one for sure. That's kind of tricky. So when we have the small number, and that's the last number in our stack, like basically whenever we have the smallest number in our stack, that's going to span the entire length of the stack. So I wonder if we do actually need to have the previous always. I want to say no. I want to say no, but I'm also not sure. Yeah, I think we don't need to have the previous always. Well, yeah, so basically, like, if you have a rectangle and you put it in, and let's say this is like decreasing, like this case. So this value actually, this rectangle actually needs to go all the way to the end and all the way this way. So whenever you only have one value left, that value will go the whole way. And I mean, we can handle that in our logic. Alternatively, what can we do to make it easier? Because we're going increasing, like how else do we solve for that case? Yeah, like what if we just store like negative infinity at some index? Like what'll happen then, I guess? If we get negative infinity at some index, then that goes the whole, yeah, I'm thinking whenever we have one value, we just want it to cover the entire rectangle. But if it's, yeah. So as long as there's a value to the left of what we have that's smaller, then like that value will just be the one that matters. But if there's nothing, I feel like that's just the way to do it. So let's go with that. And we have to check in 2 places. So yeah, I guess let's just clean this up a little bit. So essentially what we have to do is we have to like pop this value. Yeah. Pop this value and then check, was it the only value left? Basically. So we can pop the value, so we can go like IV, or not IV, we don't want to use IV. Let's go like J V2 or something. Stack pop. Alright. Now cur equals J, or not J, I minus J times V2 if there is a stack still. Otherwise, it's going to go the whole way from the start to here. So that's just, so if we're at index 3, let's say, that's going to be the whole thing. So that's just I times V2 like that. And then we do this guy. Okay. And then we kind of have to do the same thing here. So cur equals, so V times, yeah, I guess this is in parentheses. And this is in parentheses. Okay. So cur is going to equal the height, or the height will be the same no matter what. But then we have these 2 cases. So if this is the only thing in there, it's just going to be the length of the rectangle. So H, if not stack, else H minus I. And now we go cur. So let's try this case. This was kind of a hard one to find, but definitely didn't find it, so could have been better. But let's give it a go. Let's see if this is correct now. And now we should be good, because what would happen is like when this gets popped, this gets added. Then this gets added. Then yeah, this gets popped, and this is the last one left, and I think we're good. Hopefully. Ooh. Oh yeah, we don't need to do a pop because we already popped. 3. Okay. Interesting. Still got it wrong. How in the world? 420. So it's strictly decreasing. How do we get 6? I guess. So 6 is going to be where 2. Oh, it's going to be this, right? Yeah. So the 0. So basically, what will happen here is the 0 will be at some index. Then 3 is increasing. Then 2 will pop off the 3. I see. Okay, so I guess this thing is... So we actually do need to... Okay, so yeah, wrong again. So we do need to always store something on the very left. Yeah. Okay. And we just have to do it. Because, yeah, this is basically what we did and we still didn't account for it. So 2 popped off the 3. The 0 is still here, but the 2 actually takes up this whole thing. Okay, so we do need to actually check the value on the left and the right, and we do need to put something in the stack. God damn it. Okay. So we're going to put in a negative height just to make sure it doesn't matter. Like -1. And we'll make this at... where do we want to make it here, I guess? Like -1 will be the index, and -1 will be the height. And then that will tell us, right? Yeah. That will tell us like where we need to start. So then we know we can start at 0. Man, what a pain. Okay, well, I guess we have to do it, so. Okay, and now we're never going to have something smaller than -1, so we don't have to worry about all of that. So now this will be v2 times I minus stack -1, and then the index where it starts. Yeah. I think that's correct anyway, right? Like, what if we have, yeah, let's say we have 0, 3. Put something on. How far does 3 go? 0, 2. Oh, okay. No. I see. Okay, so it's more complicated. So anything we pop off, that is the index that we need to use. Yeah, whenever we have a value and we pop things off with it, that's the starting index. So I don't know if we need this, actually. I don't think so, actually. But whenever we pop things off, that's going to be our starting index. And I think that'll handle all of it. Okay, so in that case, this should just be fine. But we'll go temp equals j. And we'll start at temp equals I or something. Okay, so temp equals j. Okay. Now we append j. And then I think we're just good, hopefully. Right, let's see what we get for this guy. J. Let's see, stack append JV. What's the problem? Oh, sorry, this shouldn't be. This should be temp. Okay, this is definitely a frustrating one. Okay. Let's try this one too. Yeah, so it's essentially whenever you cover something, you need to put in that old index. 6. Is that correct? Yeah. All right, let's hope we got it. Holy shit. Okay. Yeah, so definitely it's tricky. Yeah, I mean, I think this is just a hard problem. I think I remember watching this on NeetCode where he actually gave it to some dude who was like good at competitive programming, and then he kept screwing it up. So Yeah, but luckily we figured it out. Okay, so yeah, the main thing was there. Whenever you have a smaller histogram, you need to keep changing the index to make it the other one. I mean, I'm sure there's another way to write it, but yeah. All right, so that definitely could have been better, but it is a hard problem, so I feel like missing some. I think that one honestly is like a reasonably hard problem. Like, it's like you just saw me do this video, go code it yourself, see if you can do it. It's not that easy. So I do think that one does have some like fair room for leeway to make some mistakes because that it's not super obvious. Yeah, definitely could have like dry ran it, but I mean it's kind of hard to dry run the whole thing. So yeah, I guess going over these, this one I mean I've done before, but it's super easy. This one, yeah, I know how like power works under the hood. It basically uses something like this. I don't think it does recursive. I think it does iterative with no space. So this can obviously be improved, but this is the general idea of it. I think you do like bits. Like you just take the last bit of the power and you check if it's a 0 or a 1, and if it's a 0 then you split it into like I have here, and if it's a 1 then you do the multiply by x. And you can do it in place essentially. So yeah, basically what this would look like is yeah, you can check out that solution if you want to. You just say like while n is not none, keep checking the last bit. If it's a 1, multiply your current x by x. If it's a 0, multiply yeah, basically your current multiply your current x. I guess you want like x squared. So sorry, it would be if it's a 0, you multiply your current x by the starting value, and if it's in 1, you multiply your current x by your current x. I think something like that. Yeah, and I do think there's an O1 space, and I think this is how actually power is written because it's logarithmic, not linear. So, but this is kind of similar, so good enough I think for like an interview question. Yeah, definitely this one kind of tough. And as I said, I mean I've seen someone solve it before, and maybe I have solved it like 2 years ago, but I obviously didn't remember, as you can see. So kind of a tricky one, but I mean I think it's not the worst. 30 problems, 30 minutes. One's a hard. I mean, yeah. And I guess I just missed the like I missed the one edge case the whole time, but I solved it incorrectly a few times, where basically we have to figure out like how long the smallest rectangle goes. But I am pretty happy that I got like some code really quickly, and then just needed to find that one thing. So, because I do think this is like a reasonably hard problem. But regardless, yeah, I'm going to call it here, and then going to do the Adobe one next, and I'll see you in the next one. Thanks for watching.